Take a look at this working collaborative web app. Multiple users are editing items in real time. The data is saving instantly, and the interface is fully responsive. To build a platform like this a year ago, you would need a team of developers writing thousands of lines of code. Today, the core logic and interface are driven by plain English instructions and strategic approvals. We are going to build this exact architecture from scratch. We will generate a dynamic front-end, connect a persistent Firebase database, a cloud-hosted NoSQL database that stores and syncs data in real time, add secure user authentication, and wire up a third-party API connection. We are doing all of this inside Google AI Studio. It has grown from a simple text playground into a full-stack development environment, driven by a new coding model called the Antigravity agent. Step 1 is setting up our workspace. Open Google AI Studio, navigate to the Settings panel, and select Next.js. Next.js is a React framework that allows us to build fast, server-rendered web applications. Before we type a single prompt, we have to avoid a common mistake in AI generation, the monolith trap. If left to its own devices, an AI agent will try to cram every piece of your application's logic into one massive, unstable file that will eventually collapse under its own weight. To prevent this, establish strict architectural rules in the system instructions. Command the AI to separate features into distinct files, and strictly maintain a design.md documentation tracker to map out everything it builds. Establishing these boundaries right now ensures the agent builds a modular, scalable application instead of a fragile prototype. Now we can start building. Go to the prompt bar and type your instructions for a collaborative grocery list app with a clean, modern interface. Press Enter. The Antigravity agent translates your text prompt into a complete front-end architecture, downloading necessary packages and scaffolding the interface. Once it finishes, look at the preview window. You can click the buttons, interact with the input fields, and verify that the layout matches your request. We have a functional user interface, but it has no memory. If you refresh the page right now, your grocery list disappears. To make this a true utility, we need a backend. Go back to the chat and instruct the agent to add a database for saving our lists, and to configure Google Sign-in so users can securely access their own data. Because the step involves creating external infrastructure, the agent will pause and explicitly request your approval by showing an Enable Firebase action card. Click Enable. Behind the scenes, the agent automatically provisions a Firestore database to store the grocery items and configures Firebase authentication to handle the secure sign-in flows. The application will reload in the preview window. You will now see a Google login prompt. Click it, complete the sign-in flow, and you are immediately authenticated. Setting up backend routing, complex database schemas, and secure authentication protocols usually takes an experienced developer several days. We just accomplished it by approving a single prompt. Next, let's pull in some real-world data. We will add a feature that locates nearby grocery stores using the Google Maps API. An API is a set of rules that allows our app to communicate with Google's map servers. Tell the agent to implement the map feature. It will recognize that it needs an external API key to fetch this location data, and will pause to ask you for it. Never type your API key directly into the chat or hard-code it. Instead, open the Secrets Manager in the Settings menu. Storing your keys safely as an environment variable ensures it is never exposed to the client-side browser. Using the Secrets Manager ensures your credentials remain private, which is a requirement for any software intended for real-world use. Now let's start to refine the interface. Trying to describe exact layout changes with text can be frustrating, so we will use the Visual Annotate app tool instead. Take a screenshot of your current interface, draw directly on the element you want to adjust, and provide a simple spatial instruction. The agent will process the annotated image and instantly update the code. As you continue iterating and adding features, you will hit a roadblock. The AI will eventually misunderstand a prompt, hallucinate a package, or break a functioning component. When this happens, do not waste time arguing with the agent. Use the checkpoints feature. This built-in version history lets you instantly rewind your codebase to the last stable state. However, you must be careful. Reverting your codebase does not rewind your database. If the AI changed your database structure right before it broke the app, loading an older checkpoint will create a mismatch between your code and your data. Effective development in AI Studio requires you to act as a technical director, focusing on version control and system logic rather than the underlying code syntax. Let's do a final test. Add a few items to your grocery list, close the browser tab entirely, and reopen it. Because we integrated that Firestore backend, your data perfectly persists across sessions. If you want to share this with a small team, you can generate a direct link right from AI Studio. Anyone who clicks it can use the app immediately, running on their own free Gemini API tier. But if you are ready to launch this to the public, you can deploy the finished application directly to Google Cloud Run. Google Cloud Run is a managed compute platform, a service that runs your application code without requiring you to manage individual servers, that scales stateless containers, meaning your app will remain stable whether you have 10 users or 10,000. We started with a single descriptive sentence. By enforcing strict architecture, provisioning a live database, securing our API keys, and managing our version history, we built and deployed a production-ready application. Open Google AI Studio and start your own build today.